we are going to make REST APIs using Python Flask. And we'll also talk about what kind of APIs we're going to build, what is REST, what is API, and we'll just cover the basics of building REST APIs in this video. And in the upcoming videos, we'll actually start coding up our APIs using Python. So let me just show you what the final goal or the final API is going to look like. So just give me a second. API. We have our server running, and we'll be using Postman. Let me just show you what Postman is. So for all our to check whether our APIs are working or not, we're going to use something called as Postman, which is a collaborative platform for API development. So make sure you have this downloaded. It's free to download this, and the link is postman.com. And you can use this. We'll be using this to actually build our API and see whether the API is working or not. It's pretty simple and pretty easy to use. Let me just show you what it is. And it doesn't take much time usually. And yeah, we're good to go. Awesome. So this is how the API or Postman looks like, and just don't worry about everything else. We'll be looking into all of this a bit later. If you want a dark mode, go for a dark mode. It looks pretty cool. And let's see what we have. So click on new request, and just click on new request, which is going to be an untitled request. And now we have our local host running, and we are going to develop an API for a to-do list app. So a to-do list app has a lot of features where you can add your tasks to the to-do list, you can update your tasks, and you can delete your tasks in a to-do list app. So we're going to make an API which handles all of this, handles how to add your tasks, how to update your tasks and delete your tasks, but we'll only be developing the backend or the APIs for it. Let me show you what that looks like. So let's just see all the to-dos which we have, and we have none now. So let's add some. So we add one, and you don't have to worry about what all of this is for now. I'm just showing you the final stage. So the task. The task is going to be one-on-one session with Donna on the weekend, and the summary is going to be talk about Python job / internship prep, etc. So we have this to do which you have to complete on the weekend, and we press send, and it's added to our to-do list. And now we can go to get and /todos and see that it has been added. We can add another one. So let's say 2, and let's say subscribe to programming knowledge, and with the summary being go to YouTube and do this, and we add this as well. It has been added, and to check whether our to-dos are there or not, we go and see that they are. And now let's just see delete for now. So send, and let's check whether they're deleted or not, and as you can see, it has been deleted. So this is how our final API is going to look like, where we can send requests to our URL, and we can get the information. So now before we get into the development of APIs, let's just talk about what an API is. So API is the acronym for Application Programming Interface, which is a software intermediary that allows two applications to talk to each other. So here we are talking with our backend using APIs. So we have made our API to talk to our database where we add our tasks, we update them or delete them. Now, each time you use an app like Facebook, you send a message or check the weather on your phone, you are using an API or you're using a way to communicate between two applications. So let's just see an example. So when you use an application on your mobile phone, the application connects to the internet and sends the data to a server, let's say Facebook. Then the server retrieves that data, takes the data, interprets it, performs some necessary actions, and sends it back to your phone. So this can be an example of creating a post on Facebook. You send the data of your post, the server interprets the data, performs the actions, and sends it back to your phone. So then the app that interprets your data and then presents the data in a readable way. So once you create your post, you can see your post on your timeline. And this is what an API is called, and this is what happens via an API. Now that we have a very basic understanding of an API, we come to the next concept, which is REST API, or REST stands for Representational State Transfer. Now, this is an architectural style which basically defines a set of constraints to be used while creating these web services. So now these web services have to conform to the REST architectural style, and they're called as RESTful web services, and they provide interoperability or a communication between the computer systems or your server on the internet. So they allow you to access and manipulate representations using web sources in a uniform and stateless manner. So we'll talk about what stateless means. So all we need to know is that REST is an architectural style which has a set of constraints we need to use when we create these APIs. Now let's see some basic REST concepts. So first is stateless interactions. So a REST service does not use login sessions or store any information on the server. There is no load on the server, but instead the client maintains the information about each resource, which makes REST service easier to use across load balance servers. So if you have multiple servers, where if one server crashes, you can use another server to present your data to the client. You don't have to store any login sessions on the server. The client will be maintaining all of that. Now, we talked about a set of constraints, right, which we have to follow. So these are those constraints where we have a way to communicate over HTTP, which is the Hypertext Transfer Protocol of the internet. So first is get data. So how do you get data from the server? Next is post data, or how do you actually send data to the server. Put is how you update the data, and delete is how you delete the data from the database. So these are the four things which we are going to have in our API and create and code them out in the next upcoming four videos, and we'll see how this works. So to actually make our APIs in Python and actually write the code for them, we'll be using something called as Flask RESTful. So Flask RESTful is an extension for Flask that adds support for quickly building the REST APIs. So it is a lightweight abstraction that works with your existing object relational mapping libraries. So it works with Flask seamlessly. It also encourages best practices with minimal setup. So we'll have only a single Python file, just one .api file. We'll be creating everything. And since we already have talked about Flask in a previous playlist, so we had developed a push-ups logger web app using Flask in the previous playlist. So once we are familiar with Flask, this should be very easy to pick up. So again, to install Flask RESTful, you have to follow this pip install Flask RESTful, and also make sure that you have Flask. So pip install Flask as well. And let me just do that right now, just to show you how that looks like. So we install Flask. I already have it. So the next thing is quickly install Flask RESTful. And yeah, so make sure that you have all of this and you have Python 3 as well. And let me just show you how it's going to look like. So all we are going to have is one database and one API.py file. That's it. So we are going to develop this API, which is a very common example when we start learning about REST APIs in general, how to create them. One of the most basic examples is a to-do list app or a to-do list API where we can get the APIs, create them, delete them, and it is actually do update as well now. So we have one, and let's update it. So now I don't want to update the task. The task is going to be a one-on-one session with Ronak, but the summary is going to be email him to set the call, and I can click on send. Okay, oh sorry, the server is not open, my bad. Okay, yeah, now the server is open. I'm trying, and yep. Now when we see all the tasks which we have, you can see that the summary has been updated. So this is what we're going to do. So in this video, we're going to jump straight into the code and see how we can start building our API. So in this video, the second video of the next three videos, total of 5 videos. In this video, we're going to talk about a simple basic hello world using REST APIs or using Flask RESTful. So let's see how that looks like. So first, we need to open a text editor of your choice. So it can be anything. Let me just open that here. And now make a folder called as ToDo_API and create a new file into that called as api.py. Now first we need to import Flask and Flask RESTful. So make sure that you have Flask and Flask RESTful installed. I showed you how to do that in the previous video. So let's make sure you have both them. So from Flask import Flask and from what do we need? Flask RESTful import. So we need two things. So we need resource, which is going to handle our API, and we need the API class to actually instantiate our API. So okay, now we have the two basic things we need to start building our REST API. So let's initialize our app. So app equal Flask name, and we need to initialize our API. So API is going to be API of the app. Now we have our basic API ready. So let's just start the server first. So if name equal to main app.run, and we'll just put debug equal to true. So yeah, we have our basic app ready, which is going to be running as a server at localhost 5000, port 5000. Now let's start building our app. So our app is going to have two endpoints for this hello world program. So every single API, every single endpoint, a URL endpoint. So slash todos is an endpoint, slash todos slash one is an endpoint. So slash 2, slash 3, anything. So these are two endpoints which we'll be having inside our application, where we can use 1, 2, or 3 to actually see or interact with a specific task in the to-do list, and slash to-dos will be an endpoint to see all of our to-dos, all of our tasks which we have. So for now, for the hello world program, to see how all of this works, we're going to have two endpoints. So we actually have our endpoints written using the add resource function. So first is going to be hello world, and it's going to be slash hello world only. and the next is going to be a name. So instead of saying hello world, you're going to say hello name, and this is going to be hello world slash. So the name is going to be a string. So this is how we actually uh, make sure that the end URL accepts a string. So with these two symbols, you have string, and the name of the variable is going to be name. So now we have our two endpoints ready, hello world and hello world slash name. So here, when you have localhost 5000 slash hello world, we want we want the API to give us hello world as the result. So when you do a get to this endpoint, we need a hello slash world string to be given us, and when you do a hello world slash, let's say run, we want the output to be hello run. So this is what we're going to build today. We're going to have two get requests. One is going to be a simple get request, which is going to be pretty straightforward, which is slash hello world. And second is going to be where we pass arguments to our API. So this is an argument which is going to be a string of the variable name. So we're going to pass these arguments and see how we can get the results back from the server or get the data back from the server. So let's build our API. So first we're going to have hello world, and we're going to inherit from resource. And as these two are going to be get APIs, we have a function called as get, and this is going to take in nothing. So it's just going to show us hello world, right? So we just have to return something when the server gets a get request, and make sure that the what you return is serializable. So we're going to use JSON, JavaScript object notation, to actually return all of our information. So we're going to return the data to the hello world. So whenever the user sends a get request to slash hello world, he's going to get the result as data hello world. So what is happening here? So first, the URL is seen that you have a slash hello world. Then there is a call given to the server where you go inside this get function here, and if there are any parameters, then the parameters are used, or else you just return data as hello world. Now we need something called as hello name, where we are actually able to pass a parameter in a URL and see if that works or not. But before that, let's just run our server and see if the API is working. So I'm just going to comment this one for now. We're going to see if hello world is working or not. So we're going to see how sorry, we're going to use Postman with this. So let's run our server first. So sorry, let me go inside tools and Python 3 API py. Okay, now our server is up and running at this location. So now let's create a new request. It's going to be get and localhost 5000, and it's going to be hello world. So this is what we had here. Let me see if I can. Yeah. So now it'll just be easier for you to see. So localhost 5000 slash hello world, and we sent the request. And as you can see, we got the data as hello world, and here we got a status 200, which means that okay, our request was handled successfully. We'll talk about these status codes in the next video, but for now, we had sent a get request to hello world via HTTP, and we got the body as hello world. Now let's build the second one, which is going to be our hello world with a parameter. So class hello name, right? So hello name. Again, we're going to inherit from resource and get self, and since we are passing an argument with the variable name, we have name here. All we have to do is return data. Instead of hello world, we're going to do hello and dot format name. Sorry about that. Yeah. So now let's just get this here. Yeah, and yep, the server is running. Now, what did we do here? So for every single URL endpoint, you need to have a new class, which is kind of bad. So I was thinking of doing something where, since we have slash hello world, I wanted to mix both of them into one single class, but I was able to see that we cannot do it. So for every single URL endpoint, you need a class of its own. So now we need a hello world slash string. So now, when you pass something here, so for example, give me a second, yeah. So if you pass get localhost 5000 hello world slash Ronak, the name variable stores Ronak as a string, sends it to this function, get function, and then you can use this anywhere inside your function to do anything you want. This is how it works behind the scenes. Now let's see if this works in action. So now we have a get request but to Ronak, and we press send. And as you can see, we have our data hello Ronak here. And again, if you want anything else, so let's say programming. Sorry about that. Programming. You press send, and you get hello slash programming. So this is how we can send get requests to our server, and also have a parameterized get request sent to the server. So we'll be creating tasks using the tool, using an API which we'll be creating on our own. We'll be updating those tasks and also deleting them, and you can also have a way to get those tasks back to us using the API. So this is what we're going to do in this video and the next upcoming two videos. In this video, we'll be making our get and post request in our to-do list API. And in the next video, we'll talk about the put and delete request. And in the final video, we'll actually integrate our API with a database that can be used, which can be again then deployed and be used by everyone around the world. So let's get started. Let's start preparing our to-do list API. First, let's go into our application where we were making it. So it was, I think, to-do API, and let's open up our code. And here it is. So we had made a hello world program before, but I've deleted the hello world part from the code, and we just have a very simple Flask server with an API object instantiated. Now let's see how we can make our to-do list API. So first, we need the endpoints. We need URL endpoints for our API, right? So let's say API.addResource. This is how we add our API, and each API is going to be, each URL endpoint has to be a class in itself. So this is going to be slash reduce slash integer, and it's going to be to do ID. So this is how we are going to access each and every task in our to-do list using a to-do ID, or a unique ID which is associated with each task in our to-do list. So now let's go ahead and make our class, which is going to be to-do, and we are going to inherit from resource again. Now we are going to make a get and post request for this video. So the get request to get that particular task using the task to-do ID, and post to actually send our data back to the server, or send our task, or save our task in the server. In the fifth video, we'll be saving it in our database, but that is what we're going to do today. So let's have a get request which accepts to do ID as an argument, and now we have to return something, right? So we have to return something here, and that something is going to be the task which we can access using a to do ID. So let's make our interim database. So basically a way where we store all of our to-do lists. So it's called to-dos, and we have to always return something that is serializable, basically in JSON format. So a very close mimic of JSON in Python is dictionary. So we're going to make a dictionary and then access our task and our data using that dictionary. Sorry about that. And yeah. Now our to-dos database. So this is going to be an actual SQL database in the final video, but now we're just going to work with a simple Python dictionary. This is going to be in this format. So we'll have the to-do ID. So let's say 1, and each to-do ID is going to have the task, and the task is going to be of two. Is going to have two keys. So one is going to be task, which is, let's say, going to be write hello world program, and it's also going to have another key which is going to be a summary of the task. So let's say write the code using Python. Now each of our tasks is going to have a unique task ID here, and is also going to have the task dictionary, which is going to be having two keys, the task and the summary. Now all we have to do here is return the to-dos by the to-do ID, and this is how we can actually get our task back from the server. Now if you see here, we are actually returning the dictionary inside, or the value in which to-do ID is the key. So the value here is this piece of data, and if you see, this is already in a dictionary format, so it can directly be returned using the get request, and we don't have to serialize it any further. Now let's see this in action, and let's see if our get API actually works. So now again, we need to use Postman to actually see if we are able to get a request successfully or not. It is the easiest way to do it. So just give it a minute. It should open. So we had talked about Postman in our previous video. I had gone through very simple basics of Postman. We are not going to be using Postman in a very complicated format today. So yeah, let's wait. It shouldn't take that much time. It usually doesn't, but I don't know why it's taking a lot of time today. No problem. Should open right now. I really need to change or update my laptop, but yeah, we're here. So awesome. Now let's run our server first. So api.py. Let's just save it again. Sorry. And yeah, now we can access our task 1 using this URL endpoint, which is /todo/end. So we do /1 and press send, and we get our task, which is the task write hello world program, and the summary being write the code using Python. Now this is how we can get our task using our task ID. And now let's see how we can get a list of all of our tasks. So now we need to have a URL endpoint where you can get a list of all the tasks. So let's make more than one task here. So let's say 2, and let me copy this, and let's also have 3. So now we have 3 tasks. So let's just say this is task 2, and this is task 3, and the summary, let's say writing task 2, and the summary for this is going to be this is task 3. Now this is how we write our tasks, and we need a way to get a list of all of our tasks, right? Because we usually don't just see one single task. We want to see a list of all of our tasks in a to-do list, and then we can work with it. So now let's have another URL endpoint for this, and let's call it to-do list. So each endpoint is going to have its own class. Let's say /todos. That's it. So /todos will give us a list of all of our to-dos tasks, and to-do/to-do ID is going to give us the particular task. So let's just implement it right now. To do list, inherit from resource, and all we have to do here is return to-dos. So, oh sorry, my bad. In the get, and then we return to-dos. Now, as you see, we just have to return a list of all of them, right? And they are already in a Python dictionary, which is serializable by the server. So now what we have to do is run our server again and just have /todos here, nothing else. Press send, and as you can see, we get a list of all of our tasks. And that is how we have a get API for our to-do list API program. Now, next thing which we have to do is have a way to send a task to the server, or actually write a task, right? So this is something which we're going to do using a post request. Now, for a post request, you can just click here and go to post, and our post request is going to have a body. So basically, the body is going to be the task and the summary which we want the server to accept. And we want to make sure that the format is always like this. So it is in JSON format, and it is going to have a task and a summary key where the value is going to be string. So we want to let Flask know the kind of data we're sending back to the server. So we need to parse that data, parse the body, and then add it or append it to our Python dictionary. So for that, we need to have a request parser called as recparse right here. So using a recparse, we can add two arguments, which is our task and summary, to the post argument body, and then use that to append to our to-dos dictionary. So let's write our request parser now. So let's say task post args is going to be recparse dot request parser. Now let's add our arguments. So task dot add argument. The first is going to be task, and it's going to accept a type string, and the required is going to be true. So it is compulsory to add a task, and when a user is not able to or has not done that, then we are going to have a help here which is going to say task is required, so that the user knows what to accept and expect. And the next thing which we need is the summary. So again, a summary argument, type string, and we need a summary of our task. We are not going to make our tasks blindly. We need to add some context to our task when we have a to-do list. And yeah, so now we have a way to parse this body when we send it to the server. We have to now make use of it. So let's have a post request, self to do ID, and now we need to accept our arguments. So args equal to task post args dot parse args. So using this function parse args, we can actually get our JSON data into our server. So now the args variable contains a Python dictionary with task and the summary. And now all we have to do is first check whether our task is already there in our to-dos list or not. If it is there, then we show an error and we abort the process. And if the task is not there, then we append the task to our to-do list. So first check if the task already exists or not. So if to-do ID in to-dos. So if the key to-do ID is already there, then we abort. So abort is again a function by Flask RESTful. So we abort. We send a 409 code, and we just say task ID already taken. And if there is no to-do ID or no new task of the same ID, then we append it. So we just do to-dos, to-do ID is equal to, so we have our task, and it's going to be args task, and we have the summary is going to be args summary. So this is how we append our tasks to our to-dos Python dictionary. Now this dictionary is going to be static. It is not going to change or keep adding data to it every time we close the server, because it's a Python dictionary. It's going to get instantiated every single time we run the server. So in the fifth video and the final video, we're going to actually migrate our dictionary to an actual database, which is then going to store our data in a long-term manner. But for now, let's see how we can add or send data or post a to-do task. So yeah, our server is still running. So we have everything ready here. And now let's first see how many tasks we have. So we do a get and we press a send, and we have 3 tasks now, 1, 2, 3, as you can see here. And now let's add a 4th task. We have post to /4, and the task, and we go to raw JSON, and this is the body, task and summary. So this is the 4th task and the 4th task summary, and we press send. And my bad again, we have to return something, right? So let's return the same thing which we have added. So to-do ID. Now let's do it again. So I'll be closing the server so that we have only 3 tasks, and then we run the server again. And now let's add our 4th task again. So press send. And as you can see, we have added our 4th task. And just to confirm that we have, go back to /todos, do a get request, and you can see 4 tasks here in the output body. So this is how we have a post request, or we send data from the user to the server. So we have a post request, we have a request parser, basically, which accepts 2 arguments, task and summary. Then we take those arguments here to the server, and then we append it to our database if it does not exist, and if it exists, then we see the task ID is already taken. So this is how we have finished the get and the post request in our to-do list API. In this video, we'll talk about how we can update our tasks using the put request and delete our tasks. So we'll be doing this in this video. We'll be implementing put and delete, and in the next video and the final video, we'll actually integrate a database with our to-do list API. So let's get started. Let me open my code and see where we were before. This is where we were in the previous video, where we had implemented the get and the post request. So now what we are going to do is, under the to-do class, we're going to have 2 more requests where we can delete or update a task using the to-do ID. So first, let's implement delete, as delete is very easy to implement, and we can get that done in a really small fraction of time. So for delete, all we have to do is have a delete function with self and to-do ID of the task we want to delete, and we just have to use del to-dos of the to-do ID, delete the key value, and then return all the to-dos. And this is how we directly delete our tasks, individual tasks, using the to-do ID, using the delete request. Now we have to implement the put request, where we actually update our tasks using the REST API. Now let's do that. So put self and to-do ID. Now, since we are updating a task, we need to send some information to the server, right? So again, we need to parse our request and make sure that we have a specific way or a method in which we can edit or update our tasks. So we are going to make another request parser for the put request. So task put args is equal to request dot request parser. And now we can add our 2 arguments which we have had before, but there'll be a slight change. So now what we have to do is we people can either update the task or the summary or both. So it is optional to actually update your tasks. So we have to remove the required parameter from here, and we have to modify the help part as well. So for update, we will not have a help parameter because the user knows what he wants to update. So we'll just accept a string with task or summary, and we should be good to go. Now that we have a request parser, what we can do is implement the code to update our to-do list with the arguments which we get. So similarly, as we did in post, we do args equal to task, put args dot parse args. So now args contains what we need. So first we check whether the to-do ID is in to-dos or not. If it is not in the to-dos database, then we cannot update what is not there. So we abort, and we see that the task does not exist, so we cannot update the task. If it exists, then we have to check whether it is a task update or a summary update, and then update accordingly. So let's implement that now. So first, if to-do ID not in to-dos, then we abort with the request 404, the not found status code, and we give a message which is equal to task doesn't exist, cannot update. Now until this line of execution, we will make sure that if there is no task, then we abort the request, but if there is one, then what do we have to do? So we have to check whether we are updating the task or the summary, and then update it accordingly. So let's go ahead and do that. So first check whether if it's a task. So if args task, so we're checking if the task key exists in the args dictionary. If it doesn't, then the person is trying to update the summary, or else it's trying to update the task. So let's update the task now. So to-do ID task equal to args task. So we're just changing the task key value pair for the to-dos ID when we change the task, and we check again for summary and do the same thing, but for summary now. And in this way, we have actually updated our task, and we just return the task with the task ID. So to-dos to-do ID. Now let's see what we have done here and what is happening in the to-do list editing section. So we have a put request where we use the put request to edit a task with the to-do ID. First, we make a rule, or we make a request parser to see the way in which we want to accept our data. So we're going to accept two arguments, task and summary, task or summary, where both of them are optional and nothing is required because you are editing whatever you want and whatever you feel like. Then we parse these arguments and first check whether to-do ID is there in the to-dos database or not. The database here being the to-dos dictionary. So first we check whether the to-do ID exists. If it does not exist, then we abort the request. If the to-do ID does exist, then we check whether we are updating the task key or the summary key, and we update the database or the Python dictionary here accordingly. And then we return the task which we had updated in the output. So this is how we have almost finished our REST API implementation with Python. In the next video, the most important video is where we'll be actually adding our database, SQLite database, to our REST API, just to make sure that the entire implementation is complete. And we might also have a sixth video to actually host our API, and then we can use our phone or our laptop to check whether the API is working or not. But For now, we have finished implementing get, post, put, and delete request using our REST API. And let's just see it running first. So before we end, let's see if we can have put and delete running. So let's save our code and run our server. The server is running. First, we see our to-do list. So a get for to-dos, and we have 3. So let's edit task 3. So we do /3, and we do a put request with the body in JSON, and we just update the summary and not the task. So the summary is going to be that updated third task summary. Yeah. So now the current summary for the task 3 is this is task 3, and we are updating it to updated third task summary. And let's send the request, and we get an error. So if task, then do this. If not, so there is no task, and we make sure that there was no task. So let me see what the problem is here. There is no key error, that is the point. Just make sure that our request parser is also correct. So I think I know what the problem is. So let me just put this in double quotes, and also put summary in double quotes just to be sure. Now just check it once that we have everything which we need. So we have unexpected. Oh, I get it. So yeah, my bad. We do a put, and we run a put, and we do a put again, not a post. Cannot assign literal, so this is going to be task. Summary. So I don't see what is problem here. Unexpected token. Where? Just a minute, guys. We'll just try this again, and we should be good. Instead of update, we just have put, and put. And here as well, we just change it again. Task. Summary. And yeah, we're good to go. Let's run the code now. And end of line while scanning the let me see what the problem is here. See what the problem is. Oh, I get it. Wow, I didn't realize this was a problem. But we are good to go. Sorry about that delay. This happens sometimes. And we'll make it task. And yeah, now we'll be good. Okay, so let's update task 3. And we have updated task 3. Then we can go to get all to dos, press send, and we have task 3 updated. Now let's try to delete our task 3. So go to delete to do /3 send, and as you can see, we just have 1 and 2 tasks right now. So this is how we implement a REST API using Python and Flask. And all we have left to do is actually save our tasks into a proper database and not a Python dictionary. So in this video, we're going to do just that. We're going to save our tasks, to-do list tasks into a SQLite database, and then access our tasks from there as well. And in the next video, we'll talk about how to deploy our API on the internet so that other people can use it. And we'll talk about that in the next video. So let's get started. Let's start making our fully fledged REST API with the database. So let's see where we were in the previous video first. Let's see how our API works. So once we have the server running, we can first see that this is where we were. We had an api.py file, and we had our tasks in a Python dictionary, and we were able to write our APIs and then access our Python dictionary by converting it to JSON because it is serializable. So now let's see how it works. So we have a get on /todos. So a get on /todos will be giving you all the tasks that are there in a to-do list app right here. So yeah, we have our hello world task. And now let's build on top of this and actually integrate our SQLite database into our REST APIs. So let me close our server and go to our file. Now, since we'll be using SQLite, we'll be using something called as Flask SQLAlchemy, which is going to help us work with the database. So let's import that from Flask SQLAlchemy, import the class SQLAlchemy. And now let's write some configurations for our database. So I already have them here. Let me just get them. Yeah, so this is exactly similar to what we had done in the Flask web application tutorial, where we have a database, we configure it to where we store our database, and we instantiate our SQLAlchemy object. And now, like a generic Flask web application, we are going to be making a model, which is going to be a way where we actually map our objects to the database. So we have a class to-do model, which is going to inherit from db.model. And we're going to have 3 things. So we're going to have ID, task, and summary. So ID is going to be the primary key and the unique ID for each task. Then we have the task title and the summary. So let me just put them right here, and here we go. So we have ID, task, and summary, which is going to be an integer, string, and string respectively. The next thing which we have to do is basically create this in a database, right? Create our SQLite database. So we can do that by having a db.create all function, and this will create our SQLite database when we start our server. So we want to do that, and we have to make sure that we do this after we make our to-do model class, so that all of these rows and the table can actually be initialized in the database. And yeah, let's do this, and let's actually build or actually just create our database. So yeah, Python API.py. Yeah, as you can see with the SQLAlchemy errors, you can ignore the errors for now, but we have our database inside. So as you can see, SQLite.db. So let's comment this out because we don't need anymore. We already have our database. Let's remove our to-dos from here. So actually, let's just make it empty for now. Or let's actually remove it. Okay, so now we need to add a way to use our database with our APIs. So the first thing which we need to do is figure out how are we going to actually show our data or return our data to the client when there is a get API request, how are we going to return our to-do list? So we have to make sure that it is serializable. So it has to be JSON. So the best way to do is to use a Python dictionary, right? So we're going to actually mock that way of writing Python dictionaries by something called as resource fields. So resource fields are actually a set of rules that you have in which you have to return your API information. So if I want to return a JSON, I have to make sure that every single uh, API method which I annotate with the fields should definitely follow that as a rule. So let me show you what is happening so you can understand for yourself. So we have something called as resource fields is equal to first ID. So we want to display the ID, and this is going to be an integer. So the way we actually tell Flask is by using something called as fields. So we have ID equal to fields dot integer, and similarly we have the task and summary as the string. So let me just get it here. Yeah. So this is how every single return statement is going to look like. So we're going to return an ID, task, and summary, and all the methods which will be following this when they return a to-do list task. We have to annotate them with something called as marshal with. So once we annotate our methods with marshal with the fields, we can then use them and return the API accordingly. So now let's just annotate everything. So we have marshal with resource fields. Copy that. So we'll be returning this task in a get request. We'll be doing it in a post request and a put request. So we won't be doing it in a delete request because we have no task to show. So yeah, this is how we're going to actually inject our resource fields into the return statements. And now let's start writing the logic for having it inside a database. So the first thing which we're going to do is the post API. So we're not going to make any big changes here. So just very little changes, and you'll just see it right now. Nothing complicated to do. So once we have our arguments from the body of the post request, we have a task and summary, which you can actually use this to play with. Let me just show you what happens now. So now we do a query. So since we already covered this in the Flask tutorial, I'm not going to cover this again, but let's just see a bit of an explanation. So we have a task which we ask the database to give us by the to-do ID which we specify. And if the task already exists, then we cannot create the same task with the same task ID. So we abort. And if there is no such task, then we create a new object, and then we add that object to our database, commit the changes, and return that object to do. And now since we'll be returning a to-do object from the database, and we want that to look like this. We want an object, a Python object, to look like this. This is where fields and marshal with comes into the picture. So with resource fields, we tell that we want to return ID, task, and summary, and the marshal with annotation actually injects that rule into our method. So yeah, this is the logic for post. Let's start it for get now. So it's going to be really similar to the Python tutorials that we had for Flask. So now here we again ask the database to filter by ID, get the first task, and if the task does not exist, we cannot get it. So we say we could not find that task, and if the task is here, then we return it. And since it is again an object, Python object, and we want it to look like this, we add a marshal with. Let's go ahead with put and see how we can change that. So put is going to be pretty similar to post, but with a little changes, or similar to this actually. So again, we get the object. If there is no object, we cannot update an object, right? And if there is, then we say the task, the object properties. So we have task dot object variables. So we have task which is going to be changed, or if there is a summary, then that is also going to be changed. And then we commit our changes, return the task, and marshal it with resource fields. The last is delete. So again, pretty straightforward, nothing complicated to do here. We just have task equal to model.query. We say delete task, and we're good to go. And now we have finally added everything to our database, but we have one left, which is the another URL endpoint. So this one, we need to write something to get all the tasks, not just by task ID. So this is what I will do, but in a different way. So we're not using Marshall with resource fields here, but an actual Python dictionary, so that we can understand how this actually can work both ways, with and without resource fields. So here we do a query for all the tasks. Then we have a Python dictionary, and we just populate that Python dictionary with the task objects that we have, and we return that Python dictionary. And since Python dictionary is already serializable, we don't have to worry about marshalling it with any of the fields. So yeah, this is how we write our APIs, and let's run and see if this works or not. We have Python API.py. Oh, my bad. So return is outside function. Where? Line 40. Let's go to line 40. Oh, sorry, we don't even have a get request here. Wow. And yeah, that was my bad. And we will do now. We have our database ready. We have, let's just see if we have commented create all. Yes, we have. And let's actually make our first call. So we do a post with a body. So let's say task is going to be task 1, and the summary is going to be task 1 summary in JSON format. And if everything works smoothly, then this should work. And let's hit send. And yeah, so we have a few errors. Give me a second, guys. We'll fix them up right now. So yeah, let's create our database again. Might be some mistake with that. Happens sometimes. Don't have to worry about it. We do this. We reload, and we should have a DB. Great. We can comment this out. Save it again. And server is starting again. And we're good to go. So let's try this again. To do /1 send. And see, we were able to actually add a task to the database. And now let's actually add another one. So let's say task 2 summary. And we have /2. Let's add task 2. We will add that as well. And let's get all the tasks now. Get to-dos. No body, please. And hit send. And yeah, we have task 1 and 2 here. Now, the difference between using a Python dictionary and database is that now, even after we close the server and open it again, we'll have all of our 2 tasks ready here. So before we finish this video, let's actually just test put and delete. So put /1. I'm going to put a body. So I'm going to change summary and updating. Summary is going to be task 1 summary updated. And hit send, and it is updated now. And we can also delete it the same way and press delete, and yeah, we're good to go. So this is how we make a REST API using Flask and Python. In this video, we'll talk about how we can deploy a Flask REST API using Heroku onto the internet so that other people can use the API as well. We'll see how we can have a Flask API which was built using Flask RESTful and then deployed using Heroku, but we also have a SQLite database which is integrated with the API that will be deployed on Heroku for the internet to see. And to test whether the API has been deployed on the internet or not, we'll be using Postman to check and do some API request calls, for example, a GET request or a POST request, to see if our API is working properly or not. So let's get started. So first, I have set up an API code base where you can see how the API works. And in this video, we'll only focus on deploying that API. So let me just show you how the API looks like. So here I have an app.py file, a very simple basic Flask application, RESTful application. And here, let's just go through the code once before we actually start with the deploying steps. So here we have Flask RESTful and Flask Alchemy, which we'll be using along with Flask, and we will be deploying a to-do list API where you can do a bunch of calls to the to-do list API. For example, create a to-do list using post, update it using put, get all the to-dos using get, and also delete those to-do list tasks. So first, we set up our application, initialize all the objects that we need to initialize. We set up our to-do model class. So usually when you see a very typical Flask application, you notice that all of these models, database models, and the APIs and the code is actually separated using different files and different folders. But since this tutorial is only focused on deploying a Flask API application, I have actually uh, culminated all of them into one single app.py file. So just bear with me there. And here we have a few request passes using which we actually make sure that we get the task and the summary back from the user when they do a post or a put request. And this is our API. So we have two URL endpoints. We have a slash to-dos, which gives you all the tasks, and we have slash to-do slash the to-do ID, which will be using an integer to actually post, put, get, or delete that particular to-do list task. So this is how our Flask application looks like. Just make sure to see that we also have our app.run method here, so that we know that this app.py file is going to actually run our server and get the API up and going. So how do we deploy this using Heroku? So the process is really similar to what we used to do for a typical Flask application without the API, REST API part. So let's see how we do that. And this is going to be done using Heroku, a free Heroku deployment method. You can do it on your own PC as well. So first, we need to make a requirements.txt file. So a requirements.txt file basically has all the frameworks and modules that your code uses in order to run it properly. So we use Flask, we use Flask RESTful, we use Flask SQLAlchemy, but we don't use Gunicon. So Gunicon is basically something which will be using by the Heroku platform to actually understand that we are running a server and the server is running from app.py file. So first, before we jump on to the Heroku part, let's see how we can actually make a requirements.txt file. So first, let me just copy this part now. So copy, and now let's delete our requirements.txt file. So I'll be showing you a very nice way of doing this, not a pip freeze method, which people usually do, but we'll be using a different method to actually generate our requirements.txt file. So let's delete it now, move it to trash, and now let's go into our folder. Awesome. Now, what we can do to generate a requirements.txt file for this particular project. So this particular project is inside ToDo API folder, and we only want to have those frameworks and modules or libraries inside the requirements.txt, which are being used inside this particular directory. So the typical way to do this would be to actually have a virtual environment inside your ToDo API folder, and then freezing using pip freeze to actually get those inside requirements.txt. But since I don't feel like having to use a virtual environment for every single project that I do, so I just have a common Python environment, and then if you do a pip freeze, then it actually takes up every single library or framework which you have in your main Python environment, right? So we have something better for this, and that is called as piprex. So first we do a pip install piprex. So piprex is basically an open source project where you can actually make a requirements.txt for your particular folder only. So to do that, it's very easy. First, go inside your folder. So I'm inside ToDo API and just do piprex dot. That's it. Dot is basically telling piprex that we want to make the requirements.txt for this particular folder. Press enter, and we have a requirements.txt file right here. So as you can see, we don't have the Gunicon here because our app.py file only uses these three for now. So we just paste our Gunicon here. You don't have to mention the version, that's completely fine. And just make sure that you also have Gunicon installed. So just do a pip install Gunicon. Oh, to install Gunicon, and you're good to go. So now we have a requirements.txt file. So basically, we need the requirement.txt file so that Heroku can actually use this to set up the environment when they're deploying our application. The next thing which we need is a proc file. So a proc file is basically something which is only for Heroku. So this tells Heroku that we'll be using a Gunicon-based web server, and we will be having an app. So this is going to be app. So we're basically telling Heroku that look for an app.py file, look for an app.py file, and when you find that, run the app inside it. So we have a Flask app here. So we want Heroku to actually run the app whenever it deploys it to the internet. So we just need these two things, these two extra things, files to actually have our API up and running onto the internet and to deploy it. So now that we have our Gunicon and we have an app.py which runs a to-do list API, the next thing which we have to do is basically deploy it. So let's see how we can do that. So I won't be going through the terminal or the command line way of using Heroku because as much as easy as it is, it's really hard for somebody to visualize what is happening behind the scenes, right? So we'll be using the web interface to actually see how we can use Heroku. So make sure that you log in and you have created a free account on Heroku. So it is free to make an account, and then click on new, create new app, give your app a name. This app name is going to be the URL as well. So let's say Flask REST API. No, somebody's already in. So test. No. Yeah. So not the best name, but we can work with it for now. Press on create app. Okay, so app name must start with a letter, end with a letter. Okay. So testing. And yeah, great. Let's create our app. And now we need to give Heroku our code so that it can run it and deploy it, right? Deploy an actual server on the internet. So instead of using Heroku CLI, we'll be connecting our repo to GitHub. So we're going to actually push the code. So we're going to push the entire code which we have here to GitHub. So we have all these files. We'll be pushing all these files to GitHub very easily into like 10, 5, 2 minutes. Just create a new project, Flask, and make sure it's public. Add a README if you want to, and press create repository. Now to actually upload your files onto GitHub, all I have to do is just drag and drop them. So let's drag and drop them here, and that's it. That's all we have to do to actually upload our files to GitHub. So now that this is done, we commit the changes. This might take a few seconds, not minutes. So just bear with me here. Yeah, we're done. So we have all of our files here. We have proc file, which contains an app web Gunicon. Next, we have a README. So the README is optional, but it's always good to have a README file. We have a requirements.txt, which is basically all the library which you need. We have a database, so it's not recommended that you actually have a database on GitHub like this without any security on top of it. But since it's just a way to show you how to deploy a project, we'll be having it here. And we have our final app.py file, which has all the code which we need. And now let's see how we can connect it to GitHub. So just go to GitHub Connect. If you are not logged in, then it might ask you to log in or connect to GitHub. So I'm already connected to GitHub here. User name, so it's REST something. So I'll just put REST, and it's REST Flask. So press connect, and that's it. So you actually have connected your repository to GitHub. All you have to do now is basically say deploy branch. So we have a main branch or the master branch, which is now the main branch. And all we do is press deploy branch, and we see our API being deployed on the internet right in front of us in real time. So first, as you can see, it detected that it's a Python app since we told it in the proc file. Then it's installing Python, installing everything that you need, or all the libraries. And then the proc file declares the type as web. So it's a web server, a Unicorn web server. And now it sees where to actually launch it from. So this is our URL. So we have a URL ready, just deployed to Heroku. And just to make sure that this is actually deployed, we can just go and check it in the activity tab. And yeah, so we have successfully deployed our application. Let's see the URL for it. So this is the URL. And let's copy this URL so that we'll be testing whether our API is actually there or not. And to test whether our API is working, let's use Postman. So let me bring up Postman in the middle. Yeah. So we'll be doing a get on the API, and the endpoint is todos. So let's send this and see what happens. We press send. You can see in the body, we already have 2 tasks inside our to-do list, and this is how we actually deploy a Flask REST API on the internet using Heroku. So now, actually, if you guys actually go to this URL and the endpoint, you can actually make some put request, get request, create request to it. So go ahead. Actually, I would like to see some tasks here. Just make sure not to spam it because it's just a hobby project. And yeah, so this is how we create a to-do list, or we actually deploy our app to the internet using Heroku. So yeah, that is it, and thank you for watching. I'll see you in the next one.